Now that we can determine whether a group has a shared birthday, we're going to estimate the probability that this happens in each group. So in order to estimate this probability, we're going to simulate creating these groups many times. So we just wrote this function shares bday. This is just for one single group of size n. So let's go ahead and execute this. This is just the exact same code. And what we did before in the previous video, we would continually run this function multiple times to see each time whether it is a true or a false. So instead of just running this manually by hand, what I've done here is I've created a function that will run this function many times and then count how many times that it returns true. Okay, so let's take a look at the code. So it's going to have two inputs over here, two arguments. The first one is num people. So this is like the size of the group. This is the same as n over here. And this is the number of simulations to do. So it defaults to 100. So it'll run this like 100 times and just count how many times it returned true. So if it returned true like 70 times, then we would say there's a 70% chance, that's our estimate, that two people would share the same birthday. If it did 10 times, it'd be a 10% chance. Okay, let's see how the code works. So we're going to have a variable count that is set to 0. This will be counting whether or not the group has a same birthday. And then, so we're going to do this for the sims number of times, so 100 times in this case by default. And then we're going to run this shares bday function. We're going to execute or call this function, and we're going to pass it in the number of people in the group. So 50, 40, 30, whatever we want. And then if it is true, then we're going to add it to the count. So we're going to take advantage that true and false evaluate as 1 and 0. So if it's 0, this plus equals will not increase. If it's 1, it'll just increase. So after the end of this loop, so after the end of this 100 times, we will have some number of this group that have true, and we're going to divide that number by 100, and that'll be our probability. Okay, so let's go ahead and execute this. And now let's get this, and let's just say the number of people, let's put it at 20, and we'll keep the sims at 100. So we'll see that in this simulation, 40% of the time, there were two people that had the same birthday. Let's go up to 23 and get to 52%. Very good. If we go to 30 people in a group, we see that it's very close, 69% chance. If we go to 40 people, we get 86% chance. Now, of course, this number will change every time we do the simulation. Sometimes it'll be higher, sometimes it'll be lower, but it'll be very close to the actual number, which is right around 90%. If we change the number of simulations, like to 1,000, we'll see that we should get an even better estimate. So here, looks like it's closing in on the true number. I don't know if it's exactly 90% the true number, but it's very close to it. It might be 89% for 40. Let's go down to 10. So with 10, we're seeing that looks like it's around 12%. That will have 12% of the time, two people will have the same birthday. All right, so that is the next step in this birthday paradox is just simulating groups, some number of times. It could be 100, it could be 1,000, whatever, and then getting the number of true values, the number of times it happened, divided by the number of simulations, and that gives you the probability.